All right, so this is the video to explain the fraction assessment. I was kind of correcting everybody's paper and doing the math there, but I thought this one might just be, it's a little more efficient for me, so I can make sure I get through everyone and give everyone equal time. So I'm going to go through this, and when I do your own video, I'll probably tell you where to look and kind of think about going through. Okay. And probably I didn't need to say that. All right, here we go. So the very first three problems are just some mixed numbers with either adding, subtracting, or multiplying a fraction. Ask you to do an estimate for each and then to show some work and answer. I'm going to do the estimates first all the way through and kind of talk about that. Here again, an estimate is a round. It's like you're rounding, you're thinking about a number that is around the right number. Some of you are trying to be very, very precise and trying to do the adding and stuff. That's not estimating. Estimating is just thinking about the numbers, thinking about what makes sense, and going from there. So here I have almost 3 plus about 1, so my estimate is going to be 4. Here, actually that pen is not great. This one should be better. This one is 10 minus almost 8, so 2. And here I know when I have a whole number multiplied by a fraction, it's going to be less. It's going to be less. And 3/5 is around a half. So I'm going to say that's probably around 2 too, because I know 4 times a half is 2. I know half of 4 is 2, so 3/5 is around a half, so I feel fine saying 2. I could say maybe 2.5 if I think about it. All right, now I'm going to work the answers out. When we look at 2 5/6 plus 1 1/4, we have a couple options. We can turn these into improper fractions if we want, or we can just add the whole numbers and then add the fractions and kind of think about it that way. Let's think about improper fractions. So if I have sixths and I have 2 wholes, that would be 12 sixths, because 12 divided by 6 is 2. So if 2 is 12 sixths and I have 5 sixths, that's going to give me 17 sixths. Added 2, we have fourths, so we have 1 whole, which is 4 fourths, 5 fourths. Remember, we can never, ever, ever add fractions together if the pieces are not the same size. Just doesn't make any sense. Can't do it. We can't add denominators. We're just saying, look, these are the size pieces. This is how many pieces we have, and then we have to add the pieces together, not how big they are. Doesn't make sense to add how big the pieces are or how small they are. Just how many you have. And the only way you can add stuff together with a real knowledge is if they're the same size pieces. So we have to change these denominators to a common denominator. So if I'm looking here and I list if I have 6, 12, 18, looking at my denominator 4, 8, 12, there we go. I can change both fourths and sixths to an equivalent fraction with the denominator of twelfths. Okay, so if I look at sixths to get to twelfths, I'm multiplying by 2. So I'm going to multiply to 37 by 2 and get 34. If I look at 4, I have to multiply by 3 to get 12, so I'm going to have 15. So now I have the same size pieces. I've made the pieces smaller. So I have 5 fourths and change that into 15 twelfths, 17 sixths, 34 twelfths. Now I just add these together. I add the pieces, the amount of pieces I have, not the size of the piece, the amount of pieces I have. And 34 plus 15 is going to give me 49 twelfths. And you can leave it like that, and that's great. That's fine. You don't have to do the mixed number, but if you do want to do the mixed number, you have to understand this number down here, and that 12 of these equals 1 whole. So if I know my 12 times tables, 12, 24, 36, 48. So I can take, what was that, 12, 24, 36, 48. So I can take 4 wholes out, and that leaves me 1/12 left over. So either answer is acceptable. And there we go. So now we have 10 minus 7 and 4/5. Right off the bat, I can see that this is almost going to be 2, and I see it's 4 like 1/5 short of being actually 2. So I know the answer is going to be 2 1/5 just by looking at it. But we can do the same sort of process that we did up top. If we look at this number 7 4/5, and we think of how many holes would be 7 when it's fifths, that would be 35 fifths would give me 7 holes. So I can change that to 35 fifths and then add the 35 to the 34, and that would give me 39 fifths. And if I look at 10 and I think about fifths, I can just make that 50 fifths, because 50 divided by 5 is 10. And now I just have 50 minus 39, because we got the same amount of pieces, which gives me 11 fifths. And again, if I want to change this to a mixed number, every group of 5 I have is 1 whole. 5 fifths is 1. 2 fifths is 2. Or sorry, 5 fifths is 1. 10 fifths is 2. I have 10 fifths there. So I can take 2 out, and I have 1/5 left over, which is exactly what I thought it was going to be. Oh, and if we look at, tie my back to my estimate. Estimate was 4. That is very close to 4. Estimate's 2. Very close to 2. And then when we have 4 times 3/5, we can think of this a few ways. 4 sets of 3/5, which is 3/5 plus 3/5 plus 3/5 plus 3/5, which is 3, 6, 9, 12 fifths. We can think of 3/5 of 4, which is kind of harder to think about, but you can draw that out. Sorry about that. I think that's the easier way. I think trying to take 3/5 of the 4. I would do that if the 3/5 were on, but this is 4 sets of 3/5, so I think that makes the most sense. And then if you want to do kind of the algorithm way, any whole number is well, this means 1 whole. That's how big your piece is. 1 whole, and I have 4 of them. 4 over 1, and so 4 times 3 is 12. 1 times 5 is 5. 12 fifths. So I have 12 fifths twice. Again, if I want to change it into a mixed number, I can. 5 fifths is 1. 10 fifths is 2. So I'm going to be taking 2 out of here, and I have 2 fifths left over, which again is about 2. I thought 2.5, very close to 2.5. Yeah. Okay, so those are the first 3. Now we're going here for the following problem. Please solve, showing your work and explain your process and answer using words. We can do this a couple different ways. 3/4 of 2/3. So I can make this 2/3. And then we want to take a look at 1. Oops, that's not a great drawing. Sorry about that. 1, 2, 3/4 of that, which those cross sections are 1, 2, 3, 4, 5, 6 twelfths. So that can be 6 twelfths, because there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I have 12 pieces, and 6 of them intersect. And then if we look at 3/4 times 2/3, we can multiply the numerators to get 6 and the denominators to get 12. Whatever your written explanation is, it should be talking about the work that you did in here. So if you're saying I'm taking a look at 3/4 of 2/3, which makes the pieces smaller in relation to the whole, and then I see that there's 6 of them, or I see a half is colored in, or if you're just doing the algorithm, you can say I multiplied my numerators and my denominators and got a product. Again, if you don't understand this drawing part, that should alert you that you don't understand the concept, because if you just know how to do this, that's not going to really help you, because it won't support you when you get a wrong answer. But if you can draw things out and think about them, you're good to go. And then finally on the back we have the field. So this is a field. It's cut into 3 thirds. They're planting potatoes, tomatoes, and corn in the third. 1/3 of the field is used to plant potatoes. The farmer Juan wants to plant 4 different kinds of potatoes. He wants to plant sweet, Idaho, new, and Nevada. Juan also wants to use the same amount of space for each potato, so he wants to keep that space equal. What fraction of the field will be used to plant each different kind of potato? Please use numbers, words, and pictures and colors to show your thinking and answer. Well, I'm not going to redraw the field. I'm just going to say, okay, he wants to take the potatoes and split it into 4, which I just did there. I know these aren't equal, but again, I'm going to assume they're equal. And this is the sweet potatoes, Idaho, new, and Nevada. But the question is, what fraction of the field? So of the whole field, not here, not what fraction of the potatoes, that'd be 1/4. What fraction of the whole field is going to be used for each different potato? And so if we're just looking at one of these in regards to the whole field, okay, I don't really know what that is yet. I want to cut each of the others into 4ths, give me equal pieces so I can understand. You see, this is not an equal piece compared to these two when I don't cut these up. But now that I have equal pieces, I see that I have 1 out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 1/12 of the field will be 1 type of tomato, or potato, sorry. So if I wanted to look at numbers, I could say I have 1/3 of the field, and I'm divide that into 4 parts, and that, if I do the algorithm, I take my fraction and I multiply it by the inverse of this, which gives me 1/12. Again, check my answer. And I also drew it out. I used some different colors. So there you go. Words. Oh, I would say that it's 1/4 or 1/12. Let's say when splitting each third into 4ths, we have 12 pieces of land. The potatoes, each potato takes up 1 of those pieces, or 1/12, 12th. I never remember that one. 1/12 of the whole field. Okay, alrighty. Ciao.